This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A water heater is not properly restrained just because somebody wrapped metal around the tank. In California, the restraint has to control the tank in two separate vertical zones, and the force has to transfer into real structural framing. That is the central field decision in this lesson. Two straps in the right places, anchored into the wrong material, still fail the basic verification. Strong anchors in the wrong strap locations also miss the requirement. Based on the published General Building Study Outline, plumbing, field inspection, and project coordination fall within testable material. My focus here is the general building contractor's role. I verify the installation, coordinate the trades, recognize defects, and get the work ready for inspection. I am not teaching specialty gas piping, soldering, connector sizing, or appliance service. A storage water heater carries a substantial mass of water. During earthquake motion, the tank can try to slide, rock, and tip. A single strap around the middle may look tight, but it leaves the tank able to rotate around that one restraint zone. The upper part can move one way while the base moves another way. That is why one centered band is not the same as capturing the tank high and low. I want you to picture the restraint as two hands controlling a tall cylinder. One hand high limits upper movement. One hand low limits base movement. Put both hands at the middle, and the cylinder still has room to pivot. The code rule is not asking for decoration around the tank. It is asking for restraint geometry that limits falling and horizontal displacement. Suppose a crew installs one strong strap at dead center and fastens it well. The immediate problem is not that the strap is weak. The problem is that the arrangement does not meet the required upper and lower restraint pattern. If the tank moves, connected water or gas components can be strained. That result is possible, not guaranteed in every event, but it is exactly the kind of avoidable condition a pre-inspection review should catch. My memory connection is simple: capture high, capture low. I do not memorize this as two random bands. I remember two separate control zones. The cited California Health and Safety Code requires new, replacement, and existing residential water heaters to be braced, anchored, or strapped to resist falling or horizontal displacement from earthquake motion. The California Plumbing Code places one restraint point within the upper 1/3 of the water heater's vertical dimension and another within the lower 1/3. The lower restraint also has to remain at least 4 inches above the water heater control unit. The words within the upper 1/3 and within the lower 1/3 matter. I do not place both straps near the middle and call one upper and one lower. I look at the actual tank height and divide it mentally into 3 vertical zones. Consider a hypothetical tank body that measures 60 inches from top to bottom. 1/3 is 20 inches. The upper restraint belongs somewhere within the top 20 inches of that tank body. The lower restraint belongs somewhere within the bottom 20 inches, while still staying at least 4 inches above the control unit. This is only a simple geometry example. The field verification still follows the actual heater and its approved installation. That lower clearance creates a second check. A strap can be in the lower third and still be wrong, because it crowds the control. I want a real measured gap of at least 4 inches, not an estimate from across the room and not a strap resting against the control housing. I put the key checks into one compact reference table. The first row is the upper restraint within the upper 1/3. The second is the lower restraint within the lower 1/3. The third is the minimum 4-inch clearance above the control unit. The last 2 rows separate the anchorage substrate from the fastener itself, because those are different questions. When I review the installation, I ask both. Where is the strap on the tank, and where does the force go after it leaves the strap? That second question leads directly to the wall. Drywall, plaster, and other finished materials are not the structural anchorage. The report's Division of the State Architect Guidance calls for lag screws at least 1/4 inch in diameter, with at least 1 and 1/2 inches of penetration into a wood framing member. The important word is penetration. A long screw that passes through finished material but barely bites the stud does not provide the required wood penetration. I treat total screw length and structural bite as two different measurements. Finish thickness, a gap behind a bracket, and the strap hardware itself can consume part of the screw length. I verify that the remaining fastener actually enters the framing by the required amount. The wall layout often creates the coordination problem. The tank may sit between studs, or the strap may land where no framing member is available. That does not make drywall anchors acceptable. It means the framing plan needs solid wood blocking or a properly secured structural ledger that gives the restraint a real load path into the studs. The best time to solve that is before the wall is closed. I coordinate the water heater location, the strap elevations, and the blocking while the framing is open. Then the finished trade can close the wall without hiding a missing substrate. If the tank location changes after drywall, I do not let the plumbing crew improvise with toggle bolts. I reopen or add an approved structural anchorage solution and then restore the finish. Imagine a remodel where the finished installation looks clean. Two straps are visible, the tank is level, and every screw head is shiny. Then I trace the anchors and discover that both straps terminate in drywall toggles. I do not accept the appearance of completion. The load path ends in gypsum rather than framing. I coordinate solid blocking, connect it to the studs, then have the restraint resecured with the required lag diameter and wood penetration. This is a useful general building distinction. The plumbing subcontractor may install the heater and restraint, but the general building contractor still has to coordinate the framing substrate and recognize when the completed work cannot carry the intended load. I also avoid turning a familiar piece of thin perforated metal into an automatic approval. The research supports the required geometry and structural anchorage. It does not give me permission to assume that any band sold near the plumbing aisle is an approved seismic restraint. I verify the restraint system, its listing or approval where applicable, and the accepted installation details rather than relying on appearance alone. The tank restraint and the pipe connections solve related but different movement problems. The straps limit movement of the heater. Approved flexible connections, where required by the installation, allow the qualified plumbing trade to address relative movement at the water and gas connections. One does not replace the other. A flexible connector does not excuse missing straps. Correct straps do not excuse an unapproved or improperly installed connector. During my review, I confirm that the connection method matches the approved appliance installation and the requirements being enforced for that project. I leave connector selection, gas work, and plumbing execution to the qualified trade. This is where scope discipline matters. A general building contractor needs enough knowledge to recognize the coordination point without pretending that every specialty detail has one universal answer. If the appliance listing, approved plans, manufacturer instructions, or local authority requires a particular connection, I make sure the qualified trade resolves it before inspection. The same principle carries into sequencing. Framing provides the anchor substrate. Plumbing sets and connects the heater. Electrical may have bonding or future readiness work. The general building contractor makes sure those pieces do not collide or get concealed before they are ready. In a residential garage, I add a separate ignition check. A water heater that can generate a glow, spark, or flame must have its ignition source at least 18 inches above the floor, unless the unit is listed as flammable-vapor ignition resistant. The exception depends on the listing, not on a guess that the heater looks modern. I verify the actual listed condition before treating floor placement as acceptable. I also keep this rule separate from seismic restraint. A heater can be correctly strapped and still have an ignition elevation problem. It can also meet the garage elevation rule and still have bad anchorage. I do not stop the review at the straps because nearby plumbing conditions can affect inspection readiness. When a heater is installed in an attic, a floor ceiling assembly, or a floor-subfloor assembly where leakage can damage the building, the cited plumbing rule requires a watertight, corrosion-resistant pan with a drain at least 3/4 of an inch routed to an approved location. When a check valve, backflow preventer, or another device creates a closed-loop water system, the cited rule requires an approved, adequately sized expansion tank. The practical distinction is that this is triggered by the system condition, not simply by the presence of a water heater. The temperature and pressure relief discharge is another visible verification point. The cited California rule requires the discharge pipe to terminate outside the building between 6 and 24 inches above the ground, point downward, and end without threads. I verify that condition without turning this episode into a specialty piping lesson. Under the cited 2025 California Energy Code provision, installing a gas or propane water heater in a newly constructed dwelling also requires coordination for a future heat pump water heater. The report supports verifying a designated space and electrical pre-wiring. I treat that as a framing and electrical sequencing checkpoint, not as permission to design the electrical circuit from a plumbing checklist. These related checks reinforce one larger idea. Inspection readiness is not a pile of isolated trade details. It is the result of making sure the location, structure, plumbing, electrical coordination, and approved equipment all agree before the work is concealed or the inspector is called. I use a consistent pre-inspection walk so the visible hardware does not distract me from the hidden load path. I put that sequence into a second table. I start by confirming the heater location and the approved installation. Then I divide the tank into thirds and verify the upper and lower restraint zones. I measure the lower strap clearance above the control. After that, I follow each strap to solid framing or blocking and verify both lag diameter and wood penetration. Only then do I review the approved connection method and the other conditions that apply to the location. That order matters because it separates the questions. Is the tank captured correctly? Is the restraint connected to structure? Are the connected systems and location conditions coordinated? A clean answer to one question does not erase a defect in another. Here's a hypothetical pre-inspection example. And I enter a garage and see two heavy straps. The upper strap is in the top third. The lower strap is in the bottom third, but it touches the control housing. The anchors enter solid blocking. I do not approve 3 correct facts and ignore the 4th. I have the lower strap repositioned within the lower third while preserving at least 4 inches above the control, and then I recheck the anchors. Now change one fact. The lower strap has the proper clearance, but the blocking is only a loose board placed behind the drywall and is not secured to the framing. The visible strap location is correct, but the force still has no verified path into the structure. I coordinate a properly attached blocking solution before inspection. Change the condition again. The heater sits directly on a garage floor, and nobody can produce the listing that supports the flammable-vapor ignition resistant exception. I do not assume the exception. I verify the listing or coordinate correction, so the ignition source meets the 18-inch elevation requirement. That is the contractor judgment I want you to practice. I'm not checking whether the installation looks familiar. I am checking whether each requirement has evidence behind it. Before I call for inspection, I also confirm that no later trade loosened a strap, covered an anchor, moved the heater, or blocked access to a required connection. Final verification happens after the trades have finished affecting the area, not only when the first installer walks away. Documentation helps when the substrate will be concealed. A clear photo of open framing and blocking, along with the approved product information and inspection records required for the project, can make later verification easier. I am not replacing the inspector's authority with a photograph. I am preserving evidence of coordinated work that may no longer be visible. The full memory line is short, upper third, lower third, 4 inches clear, real wood behind it. Upper third and lower third control the tank in 2 zones. 4 inches clear protects the required separation from the control unit. Real wood behind it reminds me that the restraint has to transfer into a framing member or solid blocking, using a lag screw at least 1/4 inch in diameter with at least 1 1/2 inches of wood penetration. Then I add the location checks that apply. In a garage, I verify the 18-inch ignition elevation, unless a valid flammable-vapor ignition resistant listing supports the exception. In damage-sensitive locations, I verify the required pan and drain. In a closed-loop system, I verify the approved expansion tank. In new construction covered by the cited energy provision, I verify future heat pump space and electrical readiness. The central lesson is still the restraint load path. A band around the tank is only the beginning. I follow the force from the upper and lower restraint, through the fastener, into structural framing. That is how I separate a finished-looking installation from a verified installation. There is an audio practice quiz for this specific episode on water heater, seismic strapping, and anchoring. It is audio-based, the questions are read aloud, and you answer by tapping, because I know many people are studying while driving, working, or moving from one job to the next. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so you can stay on track through every episode until you get your license. I am building this for people doing the work and fitting study into real life, and I want to help you keep moving forward.